Hi, everybody. I'm Aaron Kirkenberger, and welcome to the SIG testing deep dive. Today, Sen Lu and Wagner are going to be presenting to you. I meant to wear my Left Shark t-shirt to represent the team spirit here, but then I realized today is May the 4th, so I had to wear my Star Wars shirt instead. So if you want to flip forward to the agenda, Sen. Today you're going to be hearing about Prow's architecture from Sen, and Cole's going to walk you through a part of Prow called Tide and sort of our merge automation and merge where we're thinking about that. And then Sen's going to give you a little bit more about the roadmap for test infra. And if we have time, questions. Thanks. Sen?
Yep. Test. Hello? Yep. Okay, let's start. So the first question you might have is, what is Prow? Assume you have all contributed to Kubernetes. Prow is something that after you open PR in Kubernetes, you might have a lot of bot interactions, someone /LGTM or /retest, and run a bunch of pre-submit for you, and also your PR gets magically auto-merged into the head of the Kubernetes branch. So that's all done by Prow. So Prow handles all the Kubernetes CI/CD. And as a part of the test infra maintainers, our job is to maintain Prow and also a bunch of other tools for Kubernetes development. So another question you might ask is I remember a year or 2 years ago, Kubernetes CI/CD runs on Jenkins, right? Yeah, that's right. And this is fine, then why do you build another system? And no, that is not fine. During the past 2 years, we had a lot of problems with Jenkins. So for example, Jenkins is very stateful. Whenever we want to update the Jenkins version or the Docker version, we need to restart the entire Jenkins. And that will cause us to lose all our running jobs. That's kind of not acceptable, especially around the release time. And also, don't need to mention the GitHub plugins. It's really hard to maintain, and there are tons of security issues. My teammate, XD, Jeff, he was our Jenkins master. So whenever we had Jenkins issues, we will talk to him, ask him to fix it. He had a record of spending an entire week on Jenkins without doing anything else. So after more and more complaining, we decided to build a new system. And you can see the dog is very unhappy here and firefighting everywhere. That's the motivation why we have Prow. Prow is a project started by SPXTR on GitHub around 2016. And we have been fully migrated to Prow from Jenkins by January this year. So we are testing Kubernetes, right? Why do we testing Kubernetes on Jenkins VMs? That doesn't make sense. So we want to test Kubernetes on top of Kubernetes. That will make it really easy to maintain and deploy. You can define your job basically as a pod spec. We will just schedule that pod for you. And Prow respond to GitHub webhooks directly, rather than we were using something called Mount GitHub, basically loops through all the open PRs and trying to do something for you. The conclusion is we know Kubernetes much better as a Kubernetes developers than Jenkins. So whenever we have some Prow issues, we just turn around, grab someone from the SIG team, and hey, please fix this Kubernetes issue for us to make our testing far better. That's a much better cycles. Okay. Next question is, sounds like Prow is awesome, right? What does Prow really do? As I mentioned, when I was a contributor to Kubernetes, for example, when I'm reviewing someone else's PR, I do /LGTM. There's this thing called KCI bot will come in and assign you and add an LGTM label. That's part of Prow. Also, when you open a PR, you have no idea who should reviewing my PR. So Prow also kicks in to suggest a reviewer for you or approver for you. Also, on the bottom of your PR, there's tons of pre-submit jobs running, some failing, some are succeeded, that's also triggered and run by Prow. And last but not least, Prow, like after your PR matches all the merge requirement, Prow will automatically merge your PR for you. And also, if you change a config file, for example, you want to add a new Prow job, Prow also understands that and update the config max for you in the Prow cluster. So there's like no manual deployment happens there. Okay, this is the meat of the talk. I'm going to walk through like how actually Prow works, how your PR is getting tested. So let's assume here we have a GitHub. Basically, it's like everything in GitHub. And we have a K8s cluster has Prow deployed. Everything starts with you open the PR, or there's a thing called FadaBot that randomly drops a /retest on your PR if your PR has a flaky test. GitHub will send out a webhook, and basically that's a GitHub event through hook. So just a legend reminder, everything with a blue square in the Prow K8s cluster is a Prow controller. What does hook do? Upon receiving the webhook, hook will make a Prow job, which is a custom resource definition, represent your job. Basically, it contains certain amount of metadata, like the status of your job, and also a pod spec on the bottom. Basically, like you define how your Prow job needs to look like. There's also a few controllers called Tide and Splice, which manages like batch merges, basically merge automations. Make sure your PR is good to be merged. Code will cover those on the merge automation part. There's also Horologium. That's a great name made by Ryan. Basically, that's a controller schedule job on a periodic basis. For example, we do Kubernetes CI build, hourly build, like every hour. Horologium will create a Prow job every hour. Okay, there's a component called Plank in the middle. What does that do? Plank is a controller. It's like an operator type. So it loops through all the created Prow jobs based on the current status of the Prow job. It will create a pod based on your job definition, basically a pod spec. Like your job can be like any pod spec. We use upstream API types. So in this case, this is an example as a Kubernetes pre-submit. We post a kubekins IDE image, start up a Kubernetes pod. It checks out your PR, runs Kubetest. It build a fresh Kubernetes from your PR. It will create a IDE cluster using your used Kubernetes built from your PR. And last, the Kubetest will trigger a Ginkgo IDE run. You are probably familiar with that. And that will talk to the IDE cluster, lives in somewhere else. So after everything, for example, on this case, the IDE test will exit 0 on succeed and 1 on failure. Just a reminder, it don't need to be that complicated. It just need, if you're using Prow, it just need to be a simple pod that returns exit 0 on succeed and 1 on failure. And we have a UI called deck. Basically, that's the Prow front end that shows up all the current running status of the job. Like yellow means the job is still running, red means the job has failed, and green means the job succeeded. And I'm saying Plank has been watching like the status of the Prow job. Whenever it sees the Prow job has been finished, it will talk back to the GitHub, basically update the GitHub context on your PR to show that, hey, your PR is great, your PR is good to go. We also have a syncer controller that's basically responsible for garbage collection, like cleaning up pods and Prow jobs after a certain amount of time. Hope that makes it clear. That's like the basic architecture of Prow, like how everything works from a GitHub webhook to a Kubernetes pod job, and it reports back to GitHub. Okay. Next part I want to talk about is the plugin for Prow. So that's like the bot automation part. How, like, if you /LGTM, the bot applies the LGTM label for you. So upon receiving a GitHub event, for example, if even it's a comment event, the hook will dispatch the event into different plugins based on either a regex match or a event type. In this case, upon receiving a /LGTM comment, the hook will forward the comment to the LGTM plugin, and the LGTM plugin will add a LGTM label to your PR. The same thing as config update plugin. When we receive a merge event, the config update plugin will check if anyone has changed the Prow config files. For example, I added a new Prow job, and that PR is merged. The config update plugin will automatically deploy the config map into the Prow cluster. And last, we made some like silly plugins. Like it doesn't. We have a lot of those. We have like meow. You can woof. You can also /joke. In this case, it will find a random cat image like from online and append to your PR. Yeah. Yeah. And we also support all kinds of customized plugins. If you want, you can always contribute to write your own plugins for Prow to use by the case community. Okay. Yay, Prow is awesome. Prow is currently adopted by a few open source projects, namely Istio, Jetstack, Kubernetes, and OpenShift. For the Prow on Kubernetes, we have 181 nodes and more than 1,000 cores. We have been running 4.3 million jobs last year. Stats from Aaron. And we have 770 different jobs, and we have set up resubmit for 31 Kubernetes repos. This is my last slide. So, hey, you might think, hey, I want to try out Prow. This looks like super complicated from my diagram. Don't be scared out. What you really need to get Prow running is anywhere you have a Kubernetes cluster, you need your GitHub token, and you need a starter.yaml. The starter.yaml is a basic manifest file for some basic Prow component. You can find it in our testing for /prow/getting-started.md. You basically apply the starter.yaml to your cluster, and you should get everything running, and then you should be able to forward your webhook from your GitHub repo to your Prow. And that should get your bot start running. Yep. Okay, I'll hand off to Ko for how we managing auto merges for Kubernetes PRs.
So our goals with automated PR merging are to merge PRs that meet specific requirements. Typically, that's determined based on labels on GitHub and other PR properties on GitHub, like what milestone it's in, whether or not the status contexts are passing. One of the reasons that we want to be able to do this instead of having people click the merge button is because GitHub does not have very granular permissions. So we have to, if we give someone access to clicking the merge button, they have access to modifying labels, and they have access to click the merge button on any PR, where we'd much prefer to use our own code ownership process with the approval plugin. Another thing that we want to do is ensure that a PR is not merged until it's tested against the most recent base branch commit. So I'll go over that a little bit more in another slide, but basically we want to make sure that the status context that you see on your PR are actually up to date with the master branch if it's been changing since your PR was tested. Importantly, it also needs to be super scalable because the Kubernetes org is enormous, and we need to be able to process thousands of open PRs in the Kubernetes repo alone, and we also want to be able to process the dozens of repos that are in the Kubernetes org. So here's why we need to test against the most recent base branch commit. So here you can see that there's a commit on master, and there's two PRs that are based off of that commit. There's a red PR and a blue PR, and they each have a merge commit that is what we're actually testing. So before we would merge the PR, we would generate this merge commit and test that to make sure that it's passing. But the problem is that if we then merge PR1 after its test is passed, this merge commit for the blue PR is no longer actually testing against the head of master. So it's possible that there's a conflict between the PRs essentially. So what we really need to do is test this commit. We want to test the one that's based off of the most recent base branch commit. And GitHub doesn't really allow us to do this super nicely because a job reports its context for the PR, and it's tied to the PR's commit, but that doesn't tell us if the base branch has been changing or not. So we need to be able to keep track of this ourselves. Another big thing is that with the scale of the Kubernetes repo specifically, we often have 50 PRs per day, and when testing takes 45 minutes to run, that would limit us to testing about 35 PRs per day if we need to do this serial testing approach where we test one PR, merge, and then test the next PR based on that. So our queue would essentially back up and we wouldn't be able to merge all the PRs that we need to do. It just wouldn't be possible. So instead, we batch PRs together, we test them together, and then we can merge them together if all of the PRs in the batch succeed. And we have a bunch of logic to handle this intelligently. Namely, if we are testing a single PR and a batch at the same time, if the single PR succeeds, even though it could be merged, we wait until we find out the results of the batch. Because if we can merge a batch, it's much more valuable because we can merge many PRs at once and clear our queue much more quickly. So batches are prioritized, and serially tested PRs that are tested individually won't merge until a batch has actually failed. So our previous solution to all of this merge automation was the submit queue. If you've contributed to Kubernetes, you might be familiar with this UI. It's currently still used for the main Kubernetes repo, but has been deprecated everywhere else. So there's some major downsides with the submit queue that we have run into. One is that each submit queue instance has a single binary and config per repo. So that means that for every repo that we have that we want to do merge automation in, we need to spin up a new deployment, a new configuration, which is a significant maintenance burden. It is also scoped to the repo. It's not scoped to branches. So that means that things in different branches are still all in the same queue, even though they could be merged separately because different branches don't affect each other. And this also kind of deters people from adopting the submit queue because they have to spin up a new deployment every time. They can't just add some configuration to a config file. One of the other major problems was that it polls for PRs and then filters through the PRs locally. And this is extremely expensive because polling for the PRs is not actually too bad, but once we get the PRs, we need to get a bunch of additional information about them, like the labels that are on them, sometimes the issue comments, things like that. And that uses a lot of API tokens. There's also complicated prioritizing logic, which is, it can be useful at times, but ultimately it's more complicated than it's worth, and it confuses contributors when their PR is not merging and something else is jumping ahead of it in the queue. The submit queue does have batch testing, like I was describing, but it was added as an afterthought. It's an extension of the submit queue, and it requires an extra Prow component to be able to coordinate with Prow to achieve all of this. And the final thing that is bad about the submit queue is that because it is not part of Prow, it does not know which base branch commit the PR has been tested against for all of our test results. It has to go off of GitHub, which, as we mentioned, doesn't know which base branch commit our tests were tested against. So in order to solve that, every time we want to merge a PR, we have to retest it right then to make sure that it actually has recent tests done against it. And that means that if the PR actually was if its tests were up to date, we are doing an unnecessary test, which is going to take 45 minutes. So our new solution to all of these problems is Tide. And it uses a GitHub search query to define all of its merge requirements. That's the major important thing about Tide. So instead of listing all the PRs and filtering through them, we just ask GitHub for all the PRs that match our mergeable query. So GitHub will just return the PRs that are mergeable, and we don't even need to know why. So that makes the logic simpler. It makes it more friendly and for GitHub users, since search query logic is more familiar for people who use GitHub. And it saves us API tokens. Another good thing about Tide is that it's got batch merging built into it as a core component. So once you set up Tide and have it working, there's a 0 configuration for batch merging. It will just happen automatically whenever it's possible. Because we're able to use so many fewer API tokens, our single instance is actually able to handle much greater scale. So we're currently merging PRs in 45 repos from a single deployment that's running in our cluster. That's compared to a max of 6 repos that we ever managed with the submit queue, and that required 6 different deployments. This is actually also using the same GitHub token that the rest of our Prow deployment is. So we're only using 1 GitHub token for all of these, whereas the submit queue would frequently, a single deployment could run through all of the tokens in an hour. So this is much more efficient. And we've replaced all of these submit queue instances except for the main Kubernetes instance, which we will hopefully be replacing soon. Because Tide runs in the Prow cluster, it actually has access to all the test data itself, and part of that data is what base branch commits we were testing against. So Tide actually has enough information to know if our tests are up to date. So therefore, we don't have to blindly retest like the submit queue does. So here's what some of the UI for Tide looks like. This is Tide's still pretty new, so the UI is still being worked on and still has some room for improvement. This image doesn't have a whole lot of action going on in the queue right now, but I just wanted to show what it looks like when there's multiple branches being tested against. Here's a more interesting one. So this will show that these PRs have been tested against the most recent commit and are both passing, and it shows that Tide just merged one of them. Another useful UI that we have is actually on the PR dashboard. This isn't specific to Tide, but it includes Tide data. And this dashboard shows a bunch of cards like this one. So it will show you all of your PRs that you have, and it will show you that tests are running for them. And also, it will show a diff of the merge requirements based on what your PR has. So it will show you what labels you're missing, what labels you need to get rid of, or any other things that are preventing your PR from being merged. And finally, Tide also has a status context that appears at the bottom of your PR, just like any other job would. And it will show you whether or not your PR is mergeable and in the pool being tested for merge, or whether or not there's actually something you need to do to make it mergeable. And if there is something that needs to be done, it will detail what that thing is in the comment. So in this case, it says that your PR is not mergeable because you're missing the LGTM label. So as I said, Tide is brand new, and there's still lots of room for improvement. So some of the things that we're planning to improve in the future are how batches are done. Specifically, we have a fixed batch size right now. We're only batching 5 PRs together at a time, and we only run 1 batch at a time. We think this could be improved by running batches of size 1, 2, 4, 8, all the way up to the log of the number of PRs that are trying to be tested. And we could run all of those batches concurrently. And that's beneficial because one of the harder things about batching is what happens when a batch fails. We don't know which PR in the batch was actually broken. So we have to have a process for kicking things out of the batch. And if we have batches of varying sizes, we'll be able to find a successful batch faster. So that's one of the improvements we want to make. We also want to make it so that you don't actually have to have all of your tests passing. Sometimes there's a status context that reports to your PR that is not actually important. Maybe it's a review status that is optional or a job that is optional, and you want to get information on it on PRs, but you don't want to require it for merge. So we want to be able to change it so that your PR, so that you can specify that certain contexts are not actually required. And additionally, there's a couple UI changes we'd like to make. Notably, on this diagram, you can see that it shows jobs that have failing tests, which is a little confusing because this is supposed to show things that are mergeable. And if your PR is failing tests, it's not going to be mergeable. So there's a couple of improvements that we want to do there. But ultimately, it's been very useful for us so far, and it's been growing very quickly. It's quickly expanded to a lot of the repos that we've used. And because it doesn't require a separate deployment, all that it takes to configure your repo to run with our instance is just adding a configuration for your query that you want to define mergeable PRs. So it's dead simple.
Yeah.
So that's Tide.
Okay. So last but not least, I'm trying to go over the roadmap for Testing Infra with Aaron's beautiful picture took. So This is the same slide I presented in the SIG update on Tuesday. Basically, what we want to do is, first, Tide is awesome from code, so we want to switch Tide for the main Kubernetes repo, and we can retire our last living semi-queue instance. And we want to split up the Prow configuration for each org or SIG, so that each SIG can own their own Prow jobs, like configurations, and I don't have to review all the Prow job change PRs. We also want to have a policy to promote or demote like merge blocking jobs. For example, we had an instance of COPS AWS job was like failing on every single PR because of there's a resource leak on AWS. So I have to like harass Justin Santa Barbara to fixing it. Instead of doing that, we can have some policy say if a pre-submit job was like consistently failing for a certain number of time, we can demote it to be non-blocking for a while until it's stabilized again. That might help our developing velocity. We're also doing a lot of conformance drive. So we want to support both running conformance tests, use Sonnet.We and Kubetest. And we have a Testgrid dashboard. I probably can just show it. Basically collects all the data from different cloud providers. Well, you're welcome to contributing your test result there. And last, we want to create a Prow bundle. We want to open source Testgrid. I mean, everyone's probably using Testgrid, but currently it's still closed source in Google. We want to open source it so that we can get open source contributors to improve that. We also want to integrating logging artifacts viewing in Prow, which we are currently using something called Gubernator, which you click on detailed link from your PR status, so that we can have native support in Prow. We also want to create a bundle between Prow and Testgrid so that we can making more people to adopt Prow. Last, I want to say thanks to all the testing infra contributors, and we also welcome everyone to contributing to testing infra. So next time you can, your GitHub avatar can show up on this page. Question time.
So I've been interested in writing some Prow plugins for a while, but the problem is that I don't have any way to test them. And I'm not like testing them against crashing, but testing them against updating, PRs in the wrong way.
There is actually a way that you can test them. There is actually a way that we can test them. We have a tool called Phony that basically just lets you provide a webhook payload that you've gotten or have generated yourself, and you can send it to hook. So that would allow you to, once you have your plugin written, you build it and compile it, and you run hook, and then you can just send a webhook straight to it. So you can run it all locally and test it that way. And there's instructions on how to do that in the README for Prow.
So we have been discussing to add logic around labels for client Go, developer change logs, for example, and we never made anything in this direction. What is the process to introduce something new, some new label process, and maybe a Pro plugin?
That's a question.
So you're asking what the process for adding a label is?
Not a label, but the whole process now. Some logic.
For a command that controls a label? So to make it PR blocking for merging, that's controlled at the Tide level. So you would say, in the Tide query, you would say that it can't have this label. So that's how you block merge on it. To actually apply the label, you typically, if you want to have a command that controls the label, or if the label is automatically applied based on the properties of the PR, you'd have a plugin that reacts to GitHub events for the PR. So either commands that control the label, or the events for the PR, so that you can inspect the state of the PR and see if the label needs to be applied. And then the plugin can determine whether or not to apply or remove the label. You just have to make a plugin for Prow.
Well, so if it's something you're interested in introducing to the community, I sort of like to say that Test Infra, we're responsible for sort of implementing the process and providing insights from the boots on the ground level. But we also really appreciate review and insight from the contributor experience SIG. So we generally like to make sure if it's something that's going to be affecting the Kubernetes project as a whole, that it's run through both of those groups. And we often have attendees from both SIGs at either SIG's meetings, so you'll generally get feedback, but sometimes you might want a more thorough review. But yeah, generally I would say the process is just open up an issue. If it's purely like a technical change in an existing thing, maybe Test Infra. If you're talking about how to change this for the Kubernetes project as a whole, you probably want an issue in the community repo since you're changing how the community does things. And we'd have an issue in Test Infra to track the technical implementation of that.
So what does happen when a test batch fails? How you recover from that?
So whenever we run a batch, we are also running a single PR from the batch. So basically whenever we need to trigger something, we trigger a batch containing that PR, and we individually test that PR. That way, if the batch fails, we can have a signal on one of the PRs in the batch to kick it out or not. Having multiple batch sizes will help us with that.
And if the PR is fine, but the batch fails, you still have 4.
Yes. So when the batch fails and that PR succeeds, since we know that PR is okay, we merge that PR, and then we run another batch with the remaining. Yeah. Yes, and that's because if something passes serially, we know that it can be merged. So yeah, and if we have to run a new batch anyways after that, we might as well run it against the newest commit on master.
And the batch test is triggered by count or by the time or by idle?
The batch testing is triggered whenever we start a serial test. They happen simultaneously. Or if there's not a batch running, I guess. So if something is somehow gotten out of sync, we'll start up a batch anyways. Yeah.
I'm trying to find those dashboards that you showed here, the dashboard of the test result, but I tried to Google it. I'm trying to find it in the comments of merged pull requests. I have no idea how to get there.
prowl.kits.io. That's like the dashboard shows our jobs running.
And people that haven't been at its talk, how do they find it?
There's a couple things. There's like a contributor cheat sheet for common pieces of testing infrastructure. We're also working on improving like our testing documentation in general. And I know that we provide links to the deck plugin if the job is currently running, I think. But I'll let Cole answer that for sure.
So if you're going to Kubernetes Testing for our main page, if you scroll down, there are all the links to all the useful dashboard you can find. Just go to github.com/kubernetes/testinfra.
Also, to answer your question more directly, since it was about the Tide dashboards, those are all linked from the Tide status. So on your PR where Tide is telling you what your state in the queue is, if you click on the link there, it will take you directly to the dashboard.
Yeah, thanks. Hey, I was so excited to contribute to this project, and I ran this on my cluster, and then I found out you guys need cluster admin to run a regular microservice because you use CRD for that. Would you be open to changing that?
No. CRDs have a bunch of advantages. We can do validation. Yeah, there's not a. I mean, if you're going to be setting up Prow in a cluster, like you probably should have admin permissions, I would think. But it's also just a one, like you're administering the cluster, so it's also a one-time setup. You just have to create the CRD, and then that's the only step that requires admin permissions. Yeah, well, using config maps or something like that is not really a viable alternative. Or at least it has a lot of downside. We'd lose a lot of the functionality of validation and other stuff like that that we get with CRDs.
Hey there. So there was a proposal around making a change to PR labeling to deal with the changeover to Tide. What's the status of that?
So I actually left a comment in the doc about that just recently. What it seems to be boiling down to is whether or not there's any possibility for PRs to be made to the master branch, but be assigned previous milestones. If we're not sure if that's actually something that occurs or if that should be allowed. If that's not allowed, then we don't actually have to write any additional code. We can just change the Tide query and we're done. If that is the case, if there are PRs in the master branch for previous releases that we need to allow to merge in addition to the current release, then we will need some sort of mechanism to control the labeling. Yeah. So I think that's all the time we have.
Yep. And thanks everyone. And you can find us on SIG Testing on Slack or Kubernetes SIG Testing at googlegroups.com. And welcome to make a contribution to Testing Infra by sending a PR to the Testing Infra repo. Thanks everyone.
Thanks.